Hi class, welcome to statistics. I'm Clara and today we're going to learn about chi-square distribution. There's three categories that we're going to learn about. The first one is the goodness of fit test, test for independence, and test of a single variance. Today we're going to learn about the goodness of fit test, and this is the first one in the chi-square distribution. This is a useful tool for whether a data set fits a particular distribution. It's whether the distribution of the two populations are the same or whether the two events might be independent of each other, whether there's a different variability that might be expected within the population. Today we will cover the first major application of the chi-square distribution, and that is the goodness of fit test. This determines if the data is a particular fit for the distribution. For example, if lottery numbers are evenly distributed, or some numbers occur at a higher frequency outcomes, and this is conducted and interpreted in the chi-square goodness of fit hypothesis test. So this is, let's see. This is the formula that we use. This right here would be the sum. The O stands for the outcome. E is expected values. Also, we're going to need to learn the degree of freedom. To find out the degree of freedom, we're going to find out the number of category, which we're going to say it's n minus 1. And that's going to give us the degree of freedom. Any questions so far? No? All right. So we're going to go ahead and go with an example, and this is the first example in your book. We're going to break that down. This is what is the distribution of the number of customers you get that enter your store. So let's say that you want to buy a store and you want to see how many customers enter your store. And the owner gives you a percentage of customers from Monday to Saturday, because Sundays the store is closed. So this is the day. Let's get a marker that works. This is your day. So we have Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Sunday is closed. And the owner says that we're going to have 10% of customers enter the store on Monday, 10 come in on Tuesday, 15 come in on Wednesday. On Thursday we have 20%, Friday we have 30, and on Saturday we have 15. Now if you add all these together, we're going to get 100%. Okay, so these are expected. Now we're going to go in and observe. Before we observed, we're going to come up with a hypothesis. So now to observe, to see if we reject or we don't reject the hypothesis, we're going to say the null hypothesis is the owner's distribution is correct, and the alternative is the owner's distribution is not correct. So we're going to try to prove or reject the hypothesis. So the observed is we see 30 customers go in on Monday. We have 14 go in on Tuesday, 34 on Wednesday, 45, 57, and 20, which gives us a total of 200 customers. We're gonna figure out the expected percentage of customers. So if 20%, if we have 200 customers, the expected customers that go in, 10% of 200 would be 20 customers. 10% of 200 is 20. 20% of 200 is 40. 30% of 200 customers is 60. And then 30 customers is Saturday. So this is the expected outcome. Then we plug this in the formula that we had earlier. So we're gonna take this all information and we plug it in the formula that we took down earlier. So we're gonna put 30, which is the observed, minus 20, which is our expected value. We're gonna square it over the observed. So we have 30 minus 20, which is observed minus expected squared, and divided by expected, which is 20. And we're gonna do this for every day. So if you plug this into the calculator, does anybody know how much you get? Okay, Carla, what do you get?
1144.
Okay, so if you're right, you get 11.44. So that's what you get. Now we're gonna use the probability of 0.05, which is 5%. So you're gonna plug that in your chi-square distribution table that you all have in your charts. So I'm gonna erase this. But first, let's have the degree factor. Let's find that out. So we have the degree factor. We had 6 minus 1. Does anybody know what our degree factor is? Anya, what is our degree factor?
5.
5. Okay, so we have 11.44 and we have a degree factor of 5. So now you're going to check out your distribution table. So what do we get? Scarlett, what do we get?
11.07.
Okay, we're right. So now our chi is 11.07. So this is our approximation of it. So this is a little less than what we get. So now what can we do? Our null hypothesis is the owner's distribution is correct, but this is less than 0.05, so less than 5%, which is actually a little smaller than what we first got. So what can we safely say about the hypothesis? Carla?
Forget.
We reject it. So we can reject the null hypothesis. All right, thank you so much, Paz. Do you have any questions?
No.
No questions? Everybody got it?
Yes.
All right, thank you. See you guys tomorrow.